Thanks everyone for joining to this live stream. In this live stream, I am going to explain you everything about evaluating AI with Haystack. Without further ado, let's start because it's full of information. I have a short presentation and demo to show you, so I'm quite excited to show you everything. First, maybe let's start with me. My name is Bilge. I work as a developer relations engineer at DeepSet for Haystack, the open source LLM framework that we have and probably that all of you know. I am based in Istanbul, Turkey, and I am available on social media. So if you like to connect, follow me on Twitter and send me a request on LinkedIn. All right. So here's today's agenda. First, we'll talk about some evaluation metrics. Then I'll show you a lot of content that we have around evaluation in Haystack. As the third item, I'll show you a demo, and then we'll discuss some next steps after the demo. I will be checking your comments during the live stream, but if you have any questions, I will be definitely answering them in the last part QA section. All right. So let's talk about the metrics first. So these are the metrics that we have in Haystack, and I'd like to briefly explain you what all of these are. The first metric is answer exact match. So this answer exact match gets the ground truth answers and the predicted answers after a pipeline is run and checks the exact match, basically. This makes sense if you are implementing an extractive question answering system and you would like to extract the exact answer from your context. Semantic answer similarity is a similar one to answer exact match, but this is for generative question answering pipelines where the answer is may not be exactly the same of your ground truth answer, but if it's semantically similar, that's enough for it to give a score of 1. Then there are 4 different metrics for documents. Document mean average precision, recall, mean reciprocal rank, and normalized discounted cumulative gain. So the mean average precision is just like precision. So how many of the retrieved documents are actually the ground truth documents? Then we have recall. Recall checks how many of the ground truth documents were actually retrieved by our retrieval. And there are 2 modes of it, multi-hit and single hit. So in single hit, only retrieving 1 ground truth document is enough for our evaluation pipeline to give the score of give a recall score of 1. Whereas in the multi-hit, we expect all ground truth documents to be retrieved, so to be in the context to get a score of 1. The mean reciprocal rank and normalized discounted cumulative gain are mostly about ranks. So mean reciprocal rank checks how well the relevant docs are positioned over the irrelevant ones. Whereas normalized discounted cumulative gain checks the exact order of documents based on the score and evaluate this rank based on those scores and how well they are in the retrieved documents. Then we have some LLM-based metrics, such as faithfulness and context relevance. So faithfulness gets the question, predicted docs, and predicted answer, and checks if the LLM has hallucinated as it generates this answer based on the documents or not. But the context relevance checks the predicted docs and see if these predicted documents, so the retrieved context, is actually relevant for the question. But both of these metrics are LLM-based metrics. So we basically instruct an LLM to do these things with the prompt. And of course, you can also come up with your own metric using LLM-based custom metrics. You can maybe check the retrieved documents and instruct your LLM to detect if these retrieved documents are child safe, for example. Or basically anything that you can instruct your LLM with is fine for LLM-based custom metrics. And then if you like to use other pre-made metrics out there, you can use evaluation frameworks such as RAGAS, FlowJudge, and DeepEval. FlowJudge is more like a model provider for evaluation, so it comes with its own models as well. For RAGAS and DeepEval, you choose your own model. All right, but yeah, this list of like metrics is long and sometimes can be a bit complex to understand which metric to use to evaluate which part of your pipeline. That's why we have prepared this table for you. So if you have some labeled data and if you like to evaluate your retrieval, then maybe you can use like the metrics that we have here. But if you don't have any labeled data, you might want to use an LLM and use the context relevance metrics. Of course, there are also other metrics that you can use to end-to-end evaluation. For these ones, since we are only using the generated answer, so the extracted answer, and the ground truth answer, so that's why we say that it's an end-to-end evaluation. And for the LLM evaluator, for this component, you can basically go wild and define your prompt as you like. So I like to also briefly mention, talk about the content that we have around evaluation. So first of all, we have a very nice blog post called Benchmarking Haystack Pipelines for Optimal Performance. So this one starts from the data set, defines the metrics, evaluates the pipeline, and checks the scores. Like it does everything end to end. So you can go ahead and check that blog post if you're interested in evaluating the whole pipeline. Then we have a evaluation walkthrough. It takes you step by step what to do to evaluate any pipeline that you have with Haystack. Then we have Haystack evaluation. It's a GitHub repository where we keep some data sets, some architectures, and Python scripts that you can use to evaluate those architectures, and the data set that you can use, of course, to evaluate your pipelines. Then we have evaluation harness. I will show you the example of evaluation harness. This is in Haystack experimental repository. This definitely helps you as you streamline your evaluation pipeline, and you'll see how easy it gets. Then, of course, we have the evaluation tutorial and documentation around evaluation. I will share the presentation in the comments after the live stream, so don't worry about trying to find them right now. Now it's demo time. Let's go. So let me share my screen instead. Yes. All right. So in this demo, I'll show you first an example data set, then we'll do some human evaluation. We'll come up with metrics, or we'll use the already made ones. We will build an evaluation pipeline with those metrics. We'll run our evaluation and then analyze the results. And in this part, I'll show you how to use evaluation harness to cover actually the previous steps as well. And in the last, I'll show you 2 examples from the evaluation frameworks that we have in Haystack. So I've already installed Haystack, sentence transformers, and PyPDF packages. And for the evaluation frameworks, I am using Ragas and FlowJudge here. So they are also installed to gain some time. So let's check out the data set that we have. Our AGOG dataset is based on the paper, and it's a collection of papers covering different topics such as transformers, large language models, but they all come in PDF format. I have uploaded all of these 13 PDF papers here to my Colab. Here they are. And they also come with 107 questions and answers generated with the assistance of GPT-4. So this is basically an LLM-generated data set. But of course, it's validated and corrected by humans. In this data set, we have ground truth answers and questions. So keep that in mind. These are the things that we have, so we need to choose our metrics accordingly. And if you like to check the PDF files and the ground truth answers and questions, you can go to this link in our Haystack evaluation repository. You'll see the data set and the files that you need there. All right. So the first thing that I do is to create an indexing pipeline and index those files to a document store. To index them, I will use an embedding model, a sentence transformers model. And since we only have like 13 PDF papers, it's not a big issue. I can just create an in-memory document store on my Colab without setting up any additional database locally or on cloud. Then I define a file path where I uploaded all of my papers. Then I define my pipeline. So I have a PDF to document converter to convert all of these files to all of these PDF files to Haystack documents. Then I have a document cleaner. Next component is the document splitter. So I split in 250 words so that each chunk has like the same length of words. Then I have my document writer and document embedder with the embedding model that I define here. I have my PDF files here. I'm not going to run this pipeline. I've already run this. So I have 690 documents already in my document store. And for me, it took around a minute if you like to reproduce it. So as the next step, I'm starting to define a RAG pipeline. So I'm going to use an OpenAI generator. So I'll need an OpenAI API key for my RAG pipeline and also for my evaluation pipeline. So that's useful. Let me just get that one, maybe run this cell again. And this is the RAG pipeline that I have. It comes with like a basic RAG prompt. The only thing that I do additionally is like if the context is empty or just like spaces, answer with none so that I can detect if the pipeline failed in finding a relevant document, and I get like a generic response for these. Then I put my context in my prompt, then I question, etc. And here I have the sentence transformers text embedder with the same embedding model. I have my retriever, my prompt builder with the prompt. Then I have my generator running on GPT-4o Mini. Then I connect these components. Let's maybe run the cell again. So it seems that my components are connected correctly. So I am almost ready to run this pipeline. So before I do any evaluation by running this pipeline, I will first do human evaluation. But as a first step of the evaluation, I will read this JSON file, and maybe let's take a look at this JSON file. It has 107 questions. So the first example is, what are the two main tasks BERT is pre-trained on? And if I scroll down, here I have the ground truth answer. So each 107 question come with a ground truth answer. So I'll just read that JSON file and put the information that I have, so the questions and the answers that I get from that document, into all questions and all answers variables. All right, so if I see the length now, I see that 107 questions, so that's good. But since I'm doing a very small demo here, maybe like I'm only going to use the first 15 questions with the first 15 answers. If you run this locally, you can use, of course, the whole questions and answers to evaluate your pipeline. Let's do that. And let's see maybe this question and answer pair. So a question that is in the dataset is, how were the questions for the multitask test source, and what are the criteria for their inclusion? And the answer is, questions were mainly collected by graduate and undergraduate students from freely available online sources, etc., etc. And let's just run the pipeline with this question and compare the answer that we get from the LLM to this answer, the ground truth answer. So by doing this, we basically check our pipeline and how well it does manually. So if I see the answer here, it's definitely longer than the ground truth answer. So it also indicates that maybe if I try to use the answer exact match metric here, it will not give a very high score as the length of the documents are not exactly the same. Sorry, the length of the answer is not exactly the same. So, but if I check the answer semantically, I can definitely see like the first sentence is almost the same. So if I do semantic answer similarity in this RAG pipeline, it should give me a high score as they basically say the same, but my answer just a slightly my answer is just slightly longer. But I can definitely fix that by going back here, changing something in my prompt, or maybe like limiting the number of tokens that I allow my generator to generate. All right. So yeah, it's time for metrics. So as I said, we can definitely use the semantic answer similarity here. As we have like the ground truth answers and of course like the answers that are generated by our pipeline. But the other metrics that we can use can only be LLM-based metrics, as we don't have any other ground truth datasets. So we don't have like ground truth documents. So we cannot use like the document precision, or if we had them ranked, we could have used document MRR, but of course it's not possible with this dataset that we have. There are workarounds for that, and I can give you some tips after the demo. So these will be the metrics that we use. Context relevance, evaluator will assess the relevancy of the retrieved context, and the faithfulness evaluator is going to basically check if there is a hallucination in the answer of the LLM. So what I do here is I will import the evaluators that I have for all of these metrics. So context relevance and context relevance evaluators. So I kind of use them interchangeably, but that makes sense, right? Because if I use this context relevance evaluator to evaluate my pipeline for context relevance. So I add all of these evaluators for these metrics to my pipeline. But something to think about here, like in this pipeline, I don't connect these components to each other because I don't need to. I just need each component to run separately. Let's do that. And we are ready to run the evaluation. So to run the evaluation, what I do is I'll first define like two lists, predicted answers and retrieved context, because I will need this information for the metrics that I define here. And I will loop over the questions. Like here I say is 10, but it's supposed to be 15. So what I do here is I basically run the pipeline for each question separately. Then I add the answer coming from the generator to my predicted answers list, and the documents that I get from the retriever to my retrieved context. Just one trick here is to, if you like to check the output of one component in a pipeline, you need to add that component into your include outputs from list. Otherwise, the pipeline will only return the output coming from the last component or the outputs that are not used by the other components in the pipeline. So this is definitely useful, especially if you're running an evaluation over your pipeline. So let's run this one. It's going to take a while because it's going to like retrieve documents for each questions, then generate answer for each query based on the retrieved documents, and it's going to do that 15 times. And based on, of course, based on the models that you are using, whether they are whether they are local models or like the models that you use through an API, this time varies a bit, but it shouldn't take longer than 1-2 minutes. And I can maybe in the meantime go and see some of the comments. Oh, okay. Yeah, it took 48 seconds. Okay, now the fun part. I love this part a lot. It's time to run the evaluation. So to run this evaluation pipeline, as I do in my regular RAG pipeline, I pass inputs to each component that is required. But one thing that you need to know is which inputs that each component need. So for context relevance, I need questions and context. And if you're curious about the inputs of each component, you can go and check the documentation. We have it written in the documentation. I've just copy-pasted the code from there. For faithfulness, I need questions, context, and predicted answers. It's going to check the hallucination. For semantic answer similarity, I will give the predicted answers that I collected here and the ground truth answers that was given by the dataset. And then I will run this pipeline and put the results into this object. And let's do that. Or maybe something that I forgot to mention here is for semantic answer evaluator, semantic answer similarity evaluator, I am again using a model. It can be a bi-encoder or cross-encoder model here that you are using, but I have decided to use the same embedding model that we use to index and retrieve data. So again, for this one, it gets, like for semantic answer similarity especially, it gets the predicted answer and the ground truth answer, generates embeddings for each of them, and calculates the similarity. All right, this part is done as well. So I am ready to analyze the results. Here, what I do is I am using this evaluation run result class from Haystack evaluation, and I will run it with a run name, the inputs that I define here, and you are free to use like the inputs that you want, and the results that I get from my evaluation pipeline. And then I create a score report and see each metric score. So, all right. So for context relevance, I got the score of 0.2. So this is not good. It means that my pipeline is actually not retrieving relevant documents to my questions. For faithfulness, it's not that bad, but it can definitely be better. For semantic answer similarity, it's 0.5. So these scores are not the best. But I can say that for context relevance and faithfulness, we are using an LLM. So we are giving the context, we are giving the answer, and we expect LLM to give a score. And based on that score, we calculate this faithfulness. So it means that if I maybe run this evaluation pipeline again, I might get different context relevance and faithfulness scores. As LLMs decide to give a score of 1 this time, for example. What I can do is, again, maybe do some sort of like manual evaluation and create this data frame. So maybe I can check the true answers and the predicted answers on this table. For example, for the first one, it seems like it's totally faithful. So there's no hallucination whatsoever. Semantic answer similarity is okay, but the context relevance is 0. I think it shows that there might be something in my context or in the prompt that I use in context relevance. For the third one, for example, faithfulness is 1, semantic answer similarity is 0.8. Actually, it's quite high, but context relevance is again 0. So this gives me a bit, like, I'm a bit suspicious, and this doesn't really convince me of having a score of 0. What I can again do is, like, this was index 2, and I can maybe go ahead and check the context and see if this is actually not relevant at all. All right. So the true answer is BERT uses a multi-layer bidirectional transformer encoder architecture, etc. I see that answer is BERT's architecture facilitates that the use of a unified model across diverse NLP tasks through its design as a multi-layer bidirectional transformers encoder. Like, it makes sense to have the semantic answer similarity of 0.8, although you see like the answer is almost the same. I see that context is where this answer comes from, but of course I don't have like explanation why I got the score of 0. So maybe I can read it after and assess why it got the score of 0. All right, let's cite this one. So this is like evaluation, regular evaluation that you can do in Haystack. But there's also like a shorter and, in my opinion, easier way of doing the same evaluation without thinking too much. And this is by evaluation harness, the tool that we have in Haystack. So what you do is since it's in Haystack experimental, you import it, but from a different path. And then we have this RAG evaluation harness. This is evaluation harness, but it's specifically designed to evaluate RAG pipelines. It means what it does is like it accepts a RAG pipeline, so the exact pipeline that we define here. Then it expects RAG components. So you need to tell a RAG evaluation harness the embedder name that you use in your pipeline, the retriever name that you use in your pipeline, generator, prompt builder, etc. But if you have used these names for each component, then you don't need to actually explicitly explain it to your evaluation harness. You can just use this default RAG architecture. And if you scroll back a bit, let me do that, and go back to our RAG pipeline, you will see that I have used exactly the same names: query embedder, retriever, prompt builder, and generator, to have a like seamless evaluation here. And the last thing that I do is to define which metrics I like to use to evaluate this pipeline. For my case, it's semantic answer similarity, faithfulness, and context relevance. And then I define the inputs. So I know that I need questions for these metrics and I need answers for these metrics. It might not be for all of them, but if I need it for at least one, I need to provide it. And the additional thing that I do is to give a RAG pipeline input. So the evaluation harness runs the RAG pipeline and then evaluates it. So it actually knows what to pass to the RAG pipeline initially. It's this questions, sorry. But I also want it to pass these questions to the prompt builder component. Or if you have any other component in your pipeline, you also need to explicitly say its inputs here. But apart from that, for the query embedder, retriever, etc., it knows the connections and it provides the inputs. And as the last step, what I do is I just run this pipeline eval harness with the inputs that I've defined here and with a run name that I have. And it does, like, the run name is not very important here. Again, it's going to take a bit of time, as I did for my evaluation, but it shouldn't take too much time as I'm only doing it for 15 questions. But just note that the evaluation harness runs the RAG pipeline and then runs the evaluation. So it does step 4. So this part, and where is that? This part as well, yeah. That's why it's also like possible that it's going to take a bit of time. Yeah, as you see, it first executes the RAG pipeline, then execute the evaluation pipeline. After that, I will just, I can again see the score report by just using this method of this evaluation harness. Last couple of seconds, I believe. Yes, it's done. And let me run this. All right, as you see, like we had the same evaluation pipeline and we had the same RAG pipeline, but the scores that we get are a bit different. That's expected. Now we have a better, now we have different scores, but they are almost aligned. So this is like quite easy approach to run evaluation. And another thing that I like is to try different RAG pipelines as well. So if you think that the model that we use in the generator, so we had used, let's go back in our RAG pipeline, the GPT-4o mini model. But if you just like to change this and test how your RAG pipeline performs afterward, then you can just override that parameter with evaluation harness like this. You just create this RAG evaluation overrides and tell that for your RAG pipeline, for the generator, you're going to use the model GPT-4. And then you provide this override to your evaluation harness with the inputs that we have defined before and run it again. Let me give this one a go. Again, it executes the RAG pipeline, but this time it uses the GPT-4 model instead of the GPT-4o mini model. And then we can compare maybe the scores and how well we did this time for the context relevance, for semantic answer similarity, and for faithfulness as well. It's going to take a bit of time. So I see great questions. All right. I'll get to these in the question answering part. And also let me know what you think about evaluation harness so far. Like, do you find it complicated or do you think that it's useful? It simplifies the process. I mean, I know that like this part is definitely like makes sense. I really love like overriding stuff without like changing the pipeline and changing it back again to the original. But there's also this comparative thing that you can do, and this is also really meaningful if you like to like compare different architectures or different settings. Let's go. Okay, fast evaluation pipeline. All right, it's the last bit. And then for the rest, I'll just show you the scores that I've already generated instead of like running the evaluation harness from scratch. Coming. All right, this is one of the reasons why you shouldn't run evaluation in your collab. Run them in Python scripts. All right, let's see the report this time. Okay, so context relevance didn't change much. Semantic answer similarity increased a bit if I compare it to this. And faithfulness, again, increased a bit. It might say that GPT-4 is better in terms of like generating answers that are more similar to the ground truth answer. All right, so let's maybe use this comparative individual scores report and compare the results of the original evaluation harness results and the second evaluation results that we use GPT for. All right, so the run name is important here. So for this is the first context relevance score that we get for the first entry. And again, like GPT-4 evaluated it the same way. Let's maybe see one that it gave different scores. It seems like it is giving the same scores for each of them. Okay, interesting. Yeah, I'll leave the results here so that you can also like go over it on your own. Let maybe hide it for now. And another thing that you can try, and don't worry, I'm not gonna try it this time, is to maybe change the top K of the retriever. So you can increase it, decrease it, and play with different top Ks with evaluation harness, and then use this comparative individual scores report to compare the context relevance scores. Maybe your LLM gives a context relevance score of 0 because you give too much context to your LLM that it doesn't need to generate that answer. That might be a problem in your pipeline. All right, so this was the evaluation harness. And let's now talk about the evaluation frameworks that we have. And I'll show you two of them, the RAGAS and the Flow Judge. So they all come with their own metrics. So RAGAS evaluator, after you define the metric, you can use it for different evaluations, for different types of evaluations. And it's the same with Flow Judge. It comes with some pre-made metrics, but you can again define a custom metric by using Flow Judge. So let's start with the Flow Judge integration, the evaluation framework that we have. Flow Judge is a language model that is specialized to evaluate pipelines, evaluate generative AI pipelines. That's why the models that you are using are more specialized on this topic and more suitable to do assessment over your pipeline. And what you do with this evaluator is you just define your metric. Here I've used the faithfulness 5-point metric. It means that it will give a score of 1 to 5 to each document and question, and checks if this answer and question can be retrieved from the context that we have. And for the model, there are different ways of running the model for Flow Judge. You can use VLLM, you can use Hugging Face. So if you go to the Flow Judge integration page that we have, you can see like all documentation that you need. And the rest is just like some settings. I ran the cell before, so I'm not gonna do it again. And the other evaluator that we have is RAGAS. Again, it comes with different metrics, but in order to compare how they handle like faithfulness, I wanted to use the faithfulness from RAGAS as well. So as the metric, I've defined this. You need an OpenAI API key to run RAGAS evaluator. So keep that in mind. You might get this error if you haven't defined an OpenAI API key environmental variable. All right. So the extra thing that you need to do here is for Haystack evaluators. So the evaluators that are pre-built in Haystack, you can use Haystack document objects directly. But for RAGAS evaluator and Haystack Flow Judge evaluators, you need to transform the retrieved context into strings. So you need to loop over the doc content and use them as strings instead of Haystack documents. So I have done it for Flow Judge and RAGAS separately, as for this one, I need like a list of strings, but for RAGAS, I need a list of strings. All right, What I do is here, I'm not going to do it because it has taken me 4 minutes to run this evaluation pipeline, but let me go over it with you. I don't have these. This is not correct, but yeah. I have the pipeline and I add the Ragas evaluator and the flow judge evaluator to my pipeline, just like I added semantic answer similarity evaluator and the context relevance evaluator. And then I provide them the inputs that they need. They need context, questions, and responses, but they might have different keys. So pay attention and try to find the exact key. Of course, if you go to the integration pages, you'll see the exact keys that you need. And after running this pipeline, you'll see that, for example, Ragas gives a score of 1 to most of the documents or most of the context and question predicted answers, a score of 1. It has like score of none. It's probably because some of the answers are none, and it means that it cannot detect, it cannot assess correctly the score, the faithfulness score of that answer. But Flow Judge Evaluator gives us more feedback. For example, it has given a feedback of this, and the score was 5. And if you read the first sentence, it says the response provided is highly consistent with the given context. And here it gives you more information why it has given that a score. Yeah, these are score of 5, 5, 5, 5, and there's a score of 1. And for this one, the output response is completely empty, providing no information about the modifications, llama, etc. It's because we probably generated an answer of none, and this was something that we had defined in our prompt, if you remember. So in that sense, Flow Judge Evaluator gives us more details in terms of like understanding what's going on in the pipeline and in the evaluation process. So this was all about the demo. It was a big one, actually. But let me maybe now take you to the next steps. What you can do, in addition to what I've just showed you, you can add a ranker to your pipeline and increase the context relevance. As I said, maybe the context was too long, or maybe they weren't exactly this context that you need to generate that answer. So adding a ranker and limiting the content might help you to increase the context relevance score. You can try local models, especially if you're dealing with like sensitive information and you don't want to use like models behind APIs. You can also do the same for evaluation. So you don't have to use OpenAI models. You can run the models locally with Ollama and then use the URL, provide that URL to your evaluator to run LLM-based evaluations with Ollama. You can change the splitting strategy. Maybe for your data, the splitting of 250 words is not right. Maybe you need to split in paragraphs. Maybe you need to use sentences. You need to try an experiment. You can generate ground truth documents for retrieval evaluation. We have a content that we are working on right now to explain you how you can generate ground truth documents for retrieval or for any type of evaluation. You can check out the evaluation walkthrough that we have to go over these steps one by one and see which materials you can use and how you can improve this pipeline further. And after you maybe deploy your pipeline to production, you can use the tracing tools such as LangFuse and Arise AI and Arise Phoenix to continuously evaluate your pipeline to see the context, to see the queries and the answers that you get, and use like LLM-based evaluators to assess your pipeline's performance even when it's running on production. So this was it. If you like to scan the presentation and the recipe, so the demo cookbook that I used, are behind those QRs. I can maybe send you the presentation and the collab notebook that I use in the chat so that you can check them right now. Let's see. All right, this is the presentation. I hope it's clickable though. Let me know if you cannot click it and I can share it with you. And if you could just click on this recipe, it will take you to the demo cookbook that I have. All right. So now it's time for me to go over the comments again and see the questions that you have. So the first question that I see is, how do I make ground truths on my own data, or I have to manually make it all? Seems slow and seems like I'd have to know all the text and all the answers already, right? Yeah, so you can use LLMs to create ground truth documents or ground truth answers, basically anything that you want, but you definitely need a human to assess these generated data set as well. Otherwise, you will just assess the performance of your pipeline based on the LLM and what LLM might think the correct way may not be the best way for you. So, like manually going over the generated data makes more sense, but there are also really nice tools that you can use to generate data sets. So there are also like great tools out there. You might want to go and check Argilla for this. And I hope this answers your question. Let me know if you have any further questions. And the question that we have is, can we use other media for input as videos, audio files, images, etc. besides PDF? Yes, you can. But it depends on how you are going to evaluate them. So what are you trying to get from those videos or audio files and images? And will you be able to convert in a form to create like vector representations, embeddings for these modality types? But of course, if you know your way, you can definitely replace the document embedder in your indexing pipeline with a video embedder and try to run the same pipeline with that. I hope this answers your questions as well. All right, another question is, what does the model use when evaluation is taking place? Oh, like there were several models. I don't know which one you were referring to, but for context relevance evaluator and the faithfulness evaluator from Haystack, we were using an OpenAI model. For RAGAS, we were using an OpenAI model as well, but for flow of judge, we were using the flow of judge model. To learn about the models and, of course, to change the models that you can use, you can check the documentation. As I said, you can also use like local models, for example, like Ollama, to change the model and use any like a large language model through Ollama to evaluate your pipeline. All right. And I'm checking the comments if I missed any questions. But it seems like that's it. All right. Thanks everyone for joining, and I hope this helped. Feel free to let us know if you have any questions on our Discord, and yeah, see you in another live stream. All right. Take care, everyone. Bye bye.